Anastasia. So we're quickly going to go over genetics with Punnett squares. I didn't want you to wait, so I'm sorry for the rudimentary outlook of what I'm using here to record with. Usually I'd pull out the big camera here. That's not a big enough square on that camera. Usually I'd pull out the bigger camera here, but I didn't want you to wait any longer, so I just want to get this shown to you. So genetics and Punnett squares come hand in hand. You will run into Punnett squares in Algebra 2, but they're also used in genetics to figure out genetic coding and the probability for genes being passed on. So let's say we're trying to figure out if someone's going to be born with blue or brown eyes. So blue eyes versus brown eyes. Now, let's say in order to have blue eyes, in fact, as a matter of fact, to have blue eyes, you have to have two recessive traits. Whereas in brown eyes, it's dominant, meaning if you have one dominant trait for blue eyes, you will have, if you have one dominant trait for brown eyes, you will have brown eyes no matter what. So to write that out, two dominant traits, in this case we'll use uppercase B's, will equal brown eyes. A dominant and a recessive trait will still yield brown eyes, because while we have one dominant and one recessive, the dominant always trumps over the recessive, resulting in the dominant trait. And the only way to have blue eyes is to have two recessive traits. So let's say the dad has two dominant traits. He's brown-eyed all the way. Oh, I don't know why I put two there, I'm sorry. And let's say the mom has blue eyes, meaning she has to have two recessives. We need to know what's the probability that their child will have blue eyes. So what you do, we start here and we go to this square. In this square, we have a dominant trait, bring that down, and the recessive trait. And we do that for each box. In this box, the dominant meets here, this recessive meets here. In this box, the dominant meets and the recessive meets. In here, this dominant meets here, this one here. And we can see that no matter what, their child will be born with brown eyes, meaning there's a 0% chance for blue eyes. But let's say this child, who's now going to have the recessive, genetic code of BB for eyes, say they have children with someone who has blue eyes. So this person now has children with someone with blue eyes, so recessive, recessive. What's the probability that their child will have blue eyes? Well, bring the big B down here. This little b goes here. In this box, this goes here again. This one comes here. Over here we have a recessive and another recessive. In here, a recessive and another recessive. We can see that 2 out of the 4 boxes, they will have blue eyes. So 2 out of 4 is 50% chance for blue eyes. And that's how Punnett squares work in genetics in terms with genetic coding. It's just to give us a probability for genes being passed on depending if they're recessive or recessive or dominant. I hope this kind of cleared things up. Let me know if it still is a little fuzzy for you, especially with the biology book. If you need me to, I can take home the biology book, send me the numbers you're having problems with, and we can go over them together through video or Google Meet, however you need help with.